think we're just missing one more.
Okay.
So we can probably go ahead and get started.
I thought too, John. Does anybody have any questions before we get started about the assignments? Try to get them in, try to keep up on time. If you have questions, Chris is there for study hall, and Mrs. Jacket, you can email her as well. Okay, I'm going to share my screen. I'm going to go to the smart board. This is week 3, level 3. The objective for today in red here is solutions to popular types of problems. Problems that you, as you go on and take any kind of college course, especially college algebra or statistics, types of problems that we should be familiar with. And so I hope some of this is reviewed, but if it's not, it's time to see that you see it, and some of it may not be reviewed. But these are several types of popular problems we ought to be able to deal with. First one we're going to look at is we're going to start doing probability. We did it with, we've already looked at a coin, flipping a coin. If you take statistics, that one's always there. And they always do a deck of cards. So if you're not familiar with cards, we're going to talk about that today and probability with them. The reason they use these two sample spaces so much is that you can actually do them and see what the sample space or how many possibilities there are. And just about any standard elementary statistics course, which many of you probably, I'm guessing, will take besides college algebra, we'll see those. We're going to look at that today. We're going to look at the quadratic formula. I can't imagine any of you taking the ACT or SAT or MAPS next year, and the quadratic formula in one way or the other, or probably several ways that it will be on there. So you should have that down, but if not, we're going to look at it. If you do, we're going to review that today. That's a very popular type of problem to solve. We're going to look at complex numbers and how they're used as it's connected with quadratic formulas. Again, that's a very common thing you should already be familiar with, but if not, it's time we looked at that as well. And then the fourth thing today, I'm going to do a little review of a couple problems from the past. So there's the objectives that we're going to do for today. Well, let's look at a deck of cards first. Probability with a deck of cards. If you're not familiar with a deck, usually when they talk about it, they're talking about a deck of 52 cards. And in that deck, there's 1, 2, 3, 4 different suits. 2 of the suits are red, the diamonds and the hearts, and 2 of the suits are black, spades and clubs. The 2s are the lowest card, the king is the highest face card, and then above those are the aces. So if you look at each of these sets, each of them would have 13. If you start counting aces 1 and go 2, 3, 4, 5, 10, Jack, Queen, King, you get 13, 13, 13, 13. If you add those up, you get 52 cards. So if you're not familiar with the deck, you will be when you take statistics. They always pull a deck or two out and do some actual problems. What it changes is when we looked at a coin, when you flip a coin, this number 52 was only 2. It could come up heads or tails. So now then you've made a big jump in how many possibilities you are. And usually in statistics, the more possibilities you have, the harder the problem is. So this ups the ante just a little bit from 2 to 52 different outcomes. If you flipped a coin twice, 2 times 2, there's only 4 outcomes. But if you draw 2 cards with replacement, I draw one, put it back in, draw again, it's 52 times 52, and that's over 2,000 possibilities. So you can see what it affects when you have a larger group of cards. So we're going to talk about that here. We're going to do some actual problems with the deck of cards. First, when you select 2 cards with replacement, then what's the probability both are 10s? And here are several other problems. We'll work them down here. When it says with replacement, that keeps the probability the same. In other words, on my first draw, I want both are 10s. There's 4 10s out of 52. Okay? On my second draw, there would only be 3 10s out of 52. Now, with replacement means this. If it's without replacement, I would say this would be 51. But it's with replacement, so I have the same. If I do the 10 of hearts, I could still draw the 10 of hearts. And that's the way this first one would look. Now, if I was doing this with the calculator, I'd just pick up and start multiplying. But if I didn't use the calculator, I'd probably reduce 4 over 52 back from the 6th and 7th grade is 1/13. I took out a 4 out of each of these. This one right here does not reduce. Pardon me. That was without replacement. With replacement, it stays at 4. It also reduces to 1/13. So my answer on this first one, is 1 times 1, multiplying fractions over 169. And the decimal, I think, is 0.6. I'd have to multiply that. You might want to check me on the calculator, but not even 1%. That's not very probable. I'm going to stop right there for a second and see if there's a question. The decimal of that, 1 divided by 169, is very close to this. So it's not even 1%. Could it happen? Yes, but it's not. It's possible. I would say it's possible, but not probable. If I was playing Daniel in cards and he did this 3 times in a row, I probably wouldn't play cards with him anymore. Wouldn't accuse him of anything, but I'd say, Daniel, I don't think I can play anymore. You've won every time, 3 times in a row. And for it happening once, it's not even 1%, it's 0.6%. We want to leave it as a fraction, we leave it that way. Sometimes we leave it as a percent. If you leave it as fraction, please do it like this. Get used to that being reduced. Any questions there before I do the next one? The answer to that one is 1 over 169. Okay, let's do the second one. And all of these are with replacement. If you do them without replacement, yeah, it is a little harder. When the sample space gets big enough, though, the with or without replacement doesn't matter. Okay, let's do the second question. Both cards are red or queens. It says or red or queen. So that changed the top number. The bottom number, if you remember probability when we flipped a coin, it's your total on bottom, and that's usually referred to as a sample space. How many, or sometimes in the population, and you'll talk about population in statistics, the total number over what's in your favor. Okay? So right here, the total is not going to change. Each time we draw, if it's with replacement, it's always 52, so that doesn't change. The hard part is figuring out what this is going to be each time. Okay, let's do the second one. Well, it's with replacement, so I know both times, both draws, is going to be 52 and 52. I can draw a red card or queen. Now let's figure that out. If there's red, half of them are red, 26. There's 13 diamonds and 13 hearts. And we could actually look at a deck and count them if we wanted to. Queens, there are 4. Now, I have a lot of students miss this because they say that top number is 30, but if you're doing queens and say 4, 2 of them are red. So I have to subtract 2. I don't want to count them twice. So really there's 28 possibilities. There's 28 out of 52 that are either red or queens. And the 2 I subtracted are the Queen of Hearts and the Queen of Diamonds. They do both. Okay? So my top number here is going to be 28. And if I wanted to, the reason in statistics course they do this, if you wanted to, you could take your deck of cards and spread them out and start counting, and sure enough, you get 28. On the second draw, let's say on the first draw, I get the 10 of hearts. Well, that's a red one of the 28. I put it back in. On the second draw, it would also be 28. Doesn't change. So that probability happening is going to be a lot higher. As I look at this, I think before I multiply them, I reduce them, just like they taught me back in grade school and middle school. That's 7/13. If you reduce 28 over 52 with or without your calculator, if you want to on your calculator right now, let's try that on a calculator. Pick up your calculator just a second. It's built in automatically. Take 28 divided by 52, just like this right here, enter. And it gives you 53, 84, 61. Right below your green alpha key, there's a math key. Hit the math key and it will say fraction. Frac. Y'all want that as a fraction? Yes. Put enter, enter. And it will say 7/13. So the calculator will do it automatically for you. I'm used to not. I was taught without, so a lot of times I'll try to do it in my head. So you always ought to check the math. The second one's the same way. It's going to be 7/13. So the answer here in fraction form, 7 times 7 is 49. 13 times 13 is 169. Now remember the last problem we had, the answer wasn't even 1%. But the probability of that happening, if you want to put it in decimal form, percent, is rounding off is 29%. It happens pretty often, almost a third of the time. So both of those would be correct. We'll stop right there on that one, because I think probably many of you haven't seen this before. If you haven't have seen it, it's probably been a while. Is there a question anyone wants to ask there? Marco?
Hello.
Thank you, Carissa. Well, let's do the last one. Let's do the last one. Okay, probability. Now, if you remember the P just right here, and then it means probability. Then inside is this event, and it says neither, neither are a 2, 3, 4, 5. Okay, so I got to think about what that means. They can't be that. So what I want, if it can't be 2, 3, 4, 5, I want a 6, 7, 8, 9, 10. Those are the counting cards. And then Jack, Queen, King. Those are the face cards. Or an ace. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 cards left. I can't have these. I took 4 away from the 13 to have 9. So in each of the suits, there's 9 that I can pick that are not 2, 3s, 4s, and 5s. So let's see if we can put that into use. So 9, I think, is what's in my favor. Remember, probability is what's in your favor divided by the total. So that probability on the first draw, I'm drawing out of 52. On the second draw, with replacement, there's still 52, the same 52 cards. That's the total. What's in the favor is this. There's 9 hearts that I could have. 9 clubs. Well, it's 4 times 9, or 36 in my favor on the first draw. There's 36 on the second draw. So I've used the same definition on all these, but what is different? These quantifiers, neither, or, both. You got to watch those. Okay, I think I'll reduce again, either with or without the calculator, it doesn't matter. I believe it's 9/13 times 9/13. 81 over 169 is the answer. If I want it in decimal form, I just go to the calculator and divide that out. And that says it's almost half the time that would happen, which is, if I round off, 48%. To the nearest percent, 48%. That's rounded off slightly. There, so I have both answers, the decimal and the fraction. So that, and in the real statistics classes there, I'd give you all a deck of cards and you would try it. And if you did it 10 times, the majority of you would be 4, 5, and 6 times it happened. You say, how does that happen, Mr. B? It's just the way the math works out if you choose at random. Also, I want to talk about this word. A lot of people don't understand random and probability. If you were in my statistics class, we'd have to talk about what random means and how you make sure draw choices at random. Any questions about those first 3? That's the first thing. We're going to work a few more examples here in just a second. Statistics. So we've talked about 2 things in statistics so far: flipping a coin 3 times and drawing 2 cards with replacement. There's many more things, but that's at least a start to it. Any questions? We'll work a few more here in just a second or 2. Okay, next item. Well, this I'm hoping you're familiar with, the quadratic formula. If you take the SAT, ACT, any of those standardized tests, if you're going to college, it's going to be on there. If you take college algebra, it's going to be on there. It's just used in so many different ways. It applies to a lot of different things as well. I'm going to solve these 2 here. Give me 1 second. I see a typo. They're quadratic. The word quadratic means 4, and usually it means you have a square term. They're called quadratics because when you factor them, you have 4 terms like x plus 3 and x minus 12 or something like this. When you factor, there's 4 terms. That's why they call them quadratics. But usually it means you have a square. Most of the time you'll hear me, if you took my college algebra class, I call that the ABC form. In other words, I have 1x squared. I have 4x. I have a minus 12 equals 0. In other words, A is 1, B is 4, and C is 12. It is very important on the quadratic formula that it equals 0. If that was a 7, I would subtract it to the other side, make sure it was 0. The formula you should have, it's one of the few things I would ask any class, college algebra class, you ought to have down by memory. Even though you can put it in, and if I didn't have it down by memory, I'd put it in my notes or know where to get it. But it says if we want to solve this equation, we have this equation, it equals something, it's supposed to equal 0. To solve it, you can use the quadratic formula. And it says this: my solution here, my x equals whatever the solution is. In other words, we could just start plugging and chugging. In other words, I would try 1. 1 plus 4 minus 12. Nope, it's not 1. Mark it off. I could try 2. 2 squared is 4. 4 times 4 is 16. 16 and 4 is 20 minus 12 is 0. Nope, it's not 2. Couldn't do that. And eventually, if you had enough patience, I suppose you could solve it. But the quadratic formula goes right to the solution. It says this, and I hope this is reviewed, but if not, it's time you saw it. It is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, if it was in a calculus class, I not only expect to use it, I'd say, why is that true? How did it form that? Right here, I'm just saying we should be able to use this on this with a great deal of accuracy and doing the arithmetic from start to finish. It handles all kinds. Now, I hope you also know when you're using quadratic equations, you could also factor, you could use completing the square, you can use graphing. There's all kinds of methods, but it seems like the quadratic formula, more questions are asked about it than any of the other methods. But I'm not going to fib to you. If I was doing these problems, the first thing I'd probably look at is factoring. Well, let's review this with the quadratic formula, see if you're okay. A, B, C. A lot of students call this cookbook math because it's just like a recipe. All I've got to do is put in what it says, when it says, and I have my answer. Opposite of B, well, there's B plus or minus, there's two answers. The fundamental theorem of algebra deals with that. In other words, on polynomials, you won't have more than two answers because it's a squared. If it was a cube, you would have more than three, or fourth degree more than four. So that's why there's a plus or minus. I might have two answers. Square root of b squared. Well, 4 times 4 is 16. Then it says minus, it says subtract all the time. 4, the number 4 is already there. A in this problem is 1. C is a minus 12. Now I was taught when it was a minus number in here, A or B, to come back here and aggrandize. So I know I changed it. It was minus in the formula. I always put a big minus through like this. That's just the way I was taught. So I know, okay, I changed that. It wasn't in the formula. All over 2a. A is 1 and 1 times 2 is 2. So there's the answer. Nearly always they would expect you to do the arithmetic. So let's do that. Four times 1 is 4. 4 times 12, in other words, I'm using PEMDAS, order of operations. 4 times 12 is 48, so I have 16 plus 48. If I add 16 to 48, I get 64. So now I have a minus 4 plus square root of 64 is 8 all over 2. So one of my answers, supposedly, 8 minus 4 is 4 over 2. It's 2. The other answer I have, it is negative 4 minus 8 over 2. That's a negative 12 over 2, which is negative 6. Now, a while ago I checked 2 and I didn't think it worked, so I'm going to check these now. They should work. That arithmetic we learned back in the 2nd, 3rd, 4th grade has to work on this. All of mathematics, you look at mathematics, up here is calculus, differential equations, infinity studies, but down here is add, subtract, multiply, and divide that we learned back starting in the 1st grade. It all sits on that, so these better work. See if I got these correct. Let's try 2. 2 squared is 4. 4 times 2 is 8. Oh, I made a mistake in arithmetic. That does equal 0. 2 is the solution. I checked it. Same thing with negative 6 if I want to check it. Let's check negative 6. Negative 6 squared is 36. I lose the negative. 4 times a negative 6 is going to be negative 24 minus 12. $36, spend $36 is 0. It works as well. They both work. And so according to the quadratic formula, it's 2 and negative 6. Now I agree. I hope what most of you are saying, or at least thinking, oh, I could have factored that one. Well, I hope you could have too. Okay? I think I would see those factors. If you want to write them out, it would have been x minus 2. You always change the sign, and x plus 6. Those would have been the factors. And you can see 2 minus 2 is 0, minus 6 plus 6 is 0. Let's work the second one, though. I don't think I would see those factors. Let's solve it with the quadratic formula. It's in the correct form, and it equals 0. So I think we're ready to go. It's not a bad idea, I think, in my opinion anyway, to say A is 1, B is 4, and C is negative 6. It doesn't matter if that x squared could have been at the end. A is still the squared term, even if they're mixed up. And again, it has to equal 0 for this formula to work. Go ahead. Take about 30 seconds and see if you can do that with the quadratic formula. That one's not quite as easy. Go. Let's see how you can do. Well, do you have your answer? Is that enough time? Let's see if I can get the right answer. Opposite of B,
They want more time, sir.
yes. Marco,
Polo.
okay, was there a question?
They just want more time. They shook their head at you. They don't have it done yet.
Maybe they were shaking their head at you, Beth.
Could be.
No, it was me, I'm sure. It's always me. If you don't believe me, Beth, just ask my wife. Always me. Give Miss Jacket a thumbs up if you're ready.
No thumbs. Carissa didn't even give me a thumbs up.
Chris is smiling. She's always ready. Look at that. Look at that. 30 more seconds. Hey, Beth,
Yes, sir.
I got a sore leg today. You know why?
No, why?
I was tap dancing last night in the kitchen, and I slipped and fell in the sink and couldn't get out. It's tap dancing. Tap dancing. Daniel just now got it. Oh, tap. Oh, here we go. Let's see if we agree or not. I hope that was enough time and you're understanding this. I hope for most of you this is review, but if not, we need to get it down. Big square root. B squared, that's 4 times 4 is 16. Always a minus, always a 4. A is 1, C is a -6. Oh, -6, that means that goes to plus. All over 2a, 2 times 1 is 2. There's the answer, but you're always expected to do the arithmetic. 4 times 1, order of operations, you come over here and multiply first, is 4. 4 times 6 is 24. Okay, so that's 40. So you have -4 plus or minus the square root of 40 all over 2. And again, that's the answer, but I would think they would expect you to cancel out. There's addition and subtraction right here. So if I start canceling something out on this division problem, I got to take it out every place. 2 out of 2 is a 1. And I could drop that 1, it's in the denominator. 2 out of -4 is a -2, plus or minus. 2, when you get, this is a big mistake I see students make all the time. When you take that 2 into the square root, it becomes a 4. I'm dividing by 4, so it's plus or minus the square root of 10. And that's probably what you'd see answers on the ACT. They would be reduced like that. Try factoring that one. Try factoring with that method. Now, I might have completed the square, would have been all right, but factoring doesn't help me with -2 plus the square root of 10. That's, I mean, that's hard enough. I don't even know, can you check that? That's another whole class in itself, adding, subtracting, multiplying, dividing polynomials that involve roots. But the quadratic formula can be helpful. I hope you're familiar with it. And if you're not, I hope this practice will help you get familiar with it. So far, there's been 2 types of common equations that I think you would see in college. One, we did the quadratic equations with quadratic formula, and the other one starting a few things in probability. The next thing is complex numbers. This right here in the quadratic formula is called the discriminant. And when it's negative, you can't do it. It's not a real number. In other words, say that discriminant instead of 10 here is the square root of negative 10. That's not a real number. Or the square root of negative 16. That's not a real number. Or the square root of a negative 25. That's not a real number. But clearly, look at these. They're all different. And all I'm saying is the same thing. It's not a real number. That's not a real number. That's not a real number. It's not a real, but they're all different. So there has to be some kind of system to tell those apart, and that's what complex numbers do. I want to talk to you about the substitution values first. And what I mean by substitution values is this. You've done it so often and so much, you do it automatically in math. You do it in other places in real life as well, but in math. In other words, don't substitute. Yeah, right, Mr. B. How do you not think this? You cannot remember when you didn't know that. That was probably taught in the first. I can't remember not knowing that, right? So we substitute all the time. This blue is abstract, and so is this green. They're just ideas. And in math, we substitute ideas all the time. Now, this doesn't seem like it's an abstract problem that, I don't know. You've seen it so much that it's not abstract to you, but really it is. No one's really seen it before. It's an idea and a symbol that we use to represent four things when it comes up. However, I bet you knew when you got this many pieces of candy and your big brother got that many pieces of candy. I bet you did, okay? And it's a concept that we teach very early in life. If you don't, in our school system, we give, it's called the dial test. And it's, we ask the students if they can count and see if they have an idea of counting and what that means. And it's one of the things they ask. So substitution values, we need to do that with complex numbers. You know how to substitute complex numbers. And again, I hope you've seen this before, but if not, it's time you did see it. Because it will come up right here, because anytime you have a square root and have negatives, I'll say, well, it's not a real number, but what is it? So here are the commonly accepted substitution values. Also, they'll build into your calculator. I'll show you that here in just a second. But anytime you have a square root of a negative, you substitute in I, little script I. If you have an I squared, we'll say that's a negative 1. A negative 1. If we have an I cubed, we'll substitute in the opposite of I. If we have I to the 4th, we'll substitute in 1. That cycle of 4 is important. Every time you get to an exponent of 4, it's going to turn back to 1. So as sure as this, I'll substitute in 2. When I see I to the 4th, I'll substitute in 1. Automatically. Okay, that's a generally accepted principle when you're working with quadratic formula and other roots. Well, let's do a couple examples and see how that might work. And this type of substitution, you did it with add, subtract, multiply, and divide. You'd expect to do the same thing with these imaginary and these substitution values. If you want to see it on your calculator, turn your calculator on. I is a number. In other words, this script I here, it is an idea. This script I. It's an idea. As sure as 2 is an idea. But it's a numerical idea. I don't know if you've noticed, but at least on the Texas Instruments, all your numerical values are white keys. They're using the same color, and on most of them it's white. Look at your calculator, right? They're white keys. So it makes sense that they would put the I in the white area. So if you want I, hit your second key, and you're going to arrow up, and look at your decimal, hit it, and you get an I. I squared, let's try that on the calculator. Do second decimal, you get an I, and hit your square key. Your square key is on the left-hand side towards the middle, and hit enter. Did it say -1? In other words, the calculator understands what these substitution values. It's just like putting 1 plus 1 in your calculator. It's going to say 2. If not, I'd want to know why. Do I cubed. Do second decimal, and then hit your cube key. It's under math. Let's say the opposite of I. Do I to the fourth. See if that one works. Second decimal, caret key, 4. Let's say 1. So you can use your calculator as well. Here's the problem with the calculator. Sometimes the way to write these numbers aren't reasonable. In other words, I want you to think what this number is. That's an idea. In fact, it's kind of a big deal, even though 0 we say is nothing. The Europeans did not have this. This is an Eastern culture idea. Okay? The first book that was published was by an Arab that had the number 0 in it. You know, you say, what do you mean the Europeans didn't have? Well, think about your Roman numerals. How do you write 10? Right? There's no 0 there. How do you write 1,000? Well, we write 1,000 like this. In Roman numerals, I believe it's an M. Right? So 0 is kind of a big deal. So when you look at these ideas on the calculator, then when I write them like this, it's not always what you expect. In other words, if I said write 0, all of you probably would have written this. However, on the calculator, sometimes when it works with these numbers, 0 might look like this. It goes to scientific notation. What that really means is this. It's this number here to the minus 12 power. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If you've never seen that before, it's awfully confusing. You know, you miss a problem. Well, the answer is 0. Well, I put this down because it's what the calculator said. Well, I want you to think about it. The calculator is trying to get to 0. It just couldn't. It's the way it's programmed. So sometimes the calculator is a little misleading. I'm just saying that as a disclaimer. Well, let's do a few problems. So now then, these problems will have solutions. In other words, right here, if I was solving this, x squared plus 16 with or without the quadratic formula, if I wanted to, I could say x squared equals a negative 16, and x, taking the square root of both sides, is a plus or minus the square root of a negative 16, or plus or minus 4i. I let the reader know with the I, it was negative. Same thing over here. X squared equals a negative 25. Or x equals a plus or minus square root of a negative 25. Or x equals plus or minus 5i. And I've let the reader know, even though they're both imaginary or not real numbers, come out differently. I let them know that I can see the difference in the problems. Let's go right to review. This is a review problem. I hope you still have that. You need equation. But let's take a look at the classwork for today. Okay, here's one of the new topics. You pick 2 cards from a deck of 52 with replacement. What's the probability? Both are kings. Both are kings. How many kings are in the deck? That would be the first thing. The deck's 52. How many kings? Well, there's 4. 2 red, 2 black. I draw one. Put it back in. Still 4 out of 52. I'm multiplying the calculator reduce. That's 1/13 times 1/13 times 1/13. 1 over 169. And the answer is C. Make sense on that? If they would have said both were red kings, that would have been 2 out of 52. 2 out of 52. 126. 126. Not nearly as probable. Next one. solve this quadratic equation. Well, that's very similar to what we just had up a minute ago. I think I would say some number squared, not using the quadratic formula. I'll use it here in a second, but it's easy because there's only an x squared. It's negative 64. Square root both sides, and x equals square root of negative 64 plus or minus. Well, that's 8i. Now, about here, at least for me, when I was in college and saw this, I said, oh, wait a minute now. How does that make that work? So I substituted in. I took 8i. Right here, 8i. 8i, and it's squared plus 64. Well, I know that 8 times 8 is 64, I squared. Now, let's see. They said the replacement value for I squared was negative 1. So this becomes negative 64. Oh, plus 64. And when I saw how it worked, I thought that's a pretty neat scheme. It actually does work when I substitute it in. The next one, number 3, I'll let you take a look at that on your own. Series and sequences, it's technical reading. You need that formula that you have on those, so do those. I think you're okay. If not, we'll talk about it later. This one is the quadratic formula. It even says equal quadratic formula. Is it in the correct form? Yes. And when I look at the answers, look at these answers. Oh, I bet it reduces. It'd be the opposite of b, plus or minus b squared minus 4 times 1 times 2 all over 2a. That would equal negative 8 plus or minus. That's 8 from 64, which is the square root of 56 all over 2. If I take out the 2's, the 2's gone. 2 into negative 8 is negative 4. It better come out this one right here. It's the only negative 4 I have. 4 into 56, sure enough, is 14. Let's take a quick look at the last two. It's what we just did. Let's look at 6 first. 108 power. Wow. I'm going to say that's I to the 4th power. 4 goes into 108 27 times. You say, well, Mr. B, why did you do that? Because I know what I to the 4th is. What is I to the 4th? It's 1 to the 27th power. The answer is 1. You say, could I have done that on my calculator? Probably. It would probably come out 1. I to the 27th. The answer is 1. This one right here, I use FOIL, just like I was taught back in middle school. 2 times 5 is 10. 5 times 5 is 25. And that's I terms. 2 times 2 is 4. I. And 2 times 5 is negative 10 I squared. $25 minus $25 plus 4 is a negative $21 on their I terms. I squared is negative 1, so that makes that a positive 10. The answer here would be 20 minus 21i. 20, answer C. So the rules, not all the rules apply, but most of them do on imaginary numbers. Anything anybody needs to add? Carissa, Beth, John, Daniel? Any questions before we stop today? I think you'll find, if you keep up with the homework, I don't know when you do it, but if it was me, I'd try to do it within 24 hours of when we saw the review. Anybody have any questions? You saw the pattern that Beth put there in the chat. That's helpful too. Thank you, Beth. No questions. Daniel, anything?
Can you go back to number 1 and number 4?
Number 4 is right there. It asks you to use the quadratic formula, and it is the opposite of b, -8, plus or minus the square root of b squared. H squared is 64 minus 4, it's always a 4, times a, which is 1. A is not always 1. C is not always 2. It's all over 2a. And then it's a matter, can you do PEMDAS, order of operations? What that means is this: you always start in here first and work your way back out of the square root. What one did you want? 4 and
Number 1.
was that the one you wanted? Number 4 first?
Yes.
Okay, number 1. There are 4 kings out of 52 and 4 kings out of 52. If you've never seen the probability for, that's, in my opinion, is probably the hardest today. And they're not, I started to say they're easy problems. None of them are easy when you see them, but if you took statistics and then look back at this, you'd say, yeah, it's pretty easy, but it takes a bit getting used to. Any other questions?
I need number 2 and number 3.
Number 2, I just took that equation and set it equal. I just took this equation right here and set it equal. Subtracted 64 and took the square root of both sides. That's number 2. And what was the other one you said?
Number 3.
Number 3, I did not do. I'm going to let you do that one on your own. Does that take a formula? Yes, it does. What kind of series or sequence is this? Is it arithmetic or geometric? Can anybody tell me? Think and blurt out. It's arithmetic. So immediately I want a sub 1. What's a sub 1? Thank you, Carissa. 2. What do you add to both sides? Or what do you add to get to the next one? It's also 2. And you need those 2 facts. Add 2, add 2, add 2, okay? And a sub 1 is 2. I would look up the formula and it asks, and that's what it asks for. In other words, I need the common difference is 2 and the ratio, or the a sub 1 is 2 and the difference is 2. If I wanted to, I could say, well, the 5th term is 10, and I could go like that, but when they start asking 25th, they could have asked, what's a 250? So you need to be able to work the formula. If not, I'll work it. Do you have the formula there in your notes? A sub n should equal a sub 1 plus the number that you're looking for. In this case, it's 25 minus 1 times the difference. And that'll give you the term. Okay? Anything else before we close? Well, those were excellent questions. And I would try to do the homework and get it turned in and take a picture, or however you're turning it in to Mr. Jacket within 24 hours. Okay, bye-bye, and I'll see you next Thursday. And remember, next Thursday, no new topics. Some of you, if you feel like you're drowning in knowledge, okay, and I get that, I understand that. We're going to stop and review next week because we're halfway finished.